out of a few steps, okay? Do you guys remember what a z-score is? What is a z-score? From chapter 3. I heard somebody say it. Okay, something to do with standard deviations. The z-score is the number of standard deviations.
Oh, it's the spread.
No, that's the standard deviation. It's the number of standard deviations from the mean. The z-score is the number of standard deviations from the mean. You guys remember how we calculate a z-score? Yeah, we take the point x, we subtract the mean, and we divide by the standard deviation. So when we did z-scores back in chapter 3, this is how we calculate it. So in chapter 3 we said z is equal to x minus x bar divided by s. Okay? In chapter 6, it's the same idea. X minus the mean divided by the standard deviation. That's equal to our z. We just change up the symbols. X minus the mean is replaced by this symbol. This is mu. It looks like a U with a line in front of it. Okay. Divided by sigma, it looks like, I don't know, a 6 that fell over. Okay. Or a Q, something. Z-score. Z-score, again, this is a definition that you should know. The number of standard deviations you are from the mean. So all normal models will have a mean and a standard deviation. Okay. The mean is mu, and the standard deviation is sigma. So it's the same. X minus the mean over the standard deviation, x minus mu over sigma. Same thing. So let's start off with an example. So the normal model, the normal distribution, looks like this. Okay. How would we describe the shape of this distribution here?
Curve.
Unimodal and symmetric. Okay. So this is unimodal and symmetric. That means numbers near the middle, are they more common or less common than the other points? Okay, so in the middle, the hill is high. So that means these are more common. If I go above the middle, more common or less common? Less common than the middle, okay? What if I go over here? Are these points more common, or are these points down here more common? Which ones are more common? No, they're equally common, right? because this is about the same height as this is, okay? So we're saying is that these ones around here, these are the most common values. The ones down here, which means they are lower, are less common, and the ones that are up here are also less common. Okay? So when we're talking about people's heights follow a normal model. Let's talk about, let's say, the height of men. In the United States, the height of men is around, the average, the mean is about 70 inches, about 5'10", give or take, half an inch or so. Okay? So for male heights in the U.S., the mean is equal to 70 inches. And the standard deviation is equal to 3 inches. So what we're saying is that men who are around 70 inches, that's around the most common height of men in the United States. Men who are around 5'10", that's very common. That's what this thing is saying. 5'10", 5'9", 5'11", those are very common heights. Okay? As you move further and further away, okay? So let's say you go 6 inches below the mean. Okay, what's 6 inches below the mean? 5'10" is the mean, so 6 inches below the mean would be
64 inches.
64 inches or 5'4". Okay? Are there men who are 5'4"?
Yes.
Yes. Are there? How do they compare in terms of how common are they versus men who are 5'9", 5'10"?
Slightly less common.
Yeah, they're less common, right? You have men who are 5'4", but there are not as many men who are 5'4" as there are men who are 5'10". Okay? What if we go 6 inches above the mean? So 70 inches plus 6 inches would take us to 76 inches, and what is that?
A little less common.
That would be
6'4".
6'4". Okay? How common are men who are 6'4"?
Not that common.
Okay, not that common. Less common than men who are 5'10". Okay? According to the normal model, men who are 6'4" and men who are 5'4", because they're both 6 inches away from the mean, they're about equally common. So you'll find just about, and this is a rough estimate, but you'll find about as many men who are 5'4" as you would men who are 6'4". Okay? And we will say, but those heights are not as common as men who are 5'10", 5'9", 5'11", things around the middle. Does that make sense? That's what it means to be unimodal and symmetric. Okay? So if we go down to 64, this is less common. If we go to 76, these are less common. Less common heights. And this is common height. We observe men who are 70 inches tall quite frequently, is what this thing says. Okay, what is the Z-score of a man who is 76 inches tall? 2. 2. Why is the Z-score 2 for a man who's 76 inches tall? Yeah, because each standard deviation is 3 inches, so the Z-score would be 76, the height, minus the mean, 70 inches, divided by 3. So the Z-score is 2. So a man who is 76 inches tall has Z-score equal to 2. Is that okay with everyone? All right, I'm going to draw a picture now. So I'm going to say 70 is right here, 76 is right here. I'm going to ask what percentage of men the US are shorter than 6'4", 76 inches? What percentage of men in the US are shorter than 6'4"? Okay, well, to answer that, we look up the Z-score, okay? So 76 has a Z-score of what? Z is equal to 2. So let's look up 2 in our Z table. Yes?
The standard deviation is given to us? Or?
Yeah, I just gave you the standard deviation. These are facts. They're approximate, okay? So Z equal to 2. How much is shaded over here?
More than
0.9772. You see that?
Yes.
Okay. So the question was, what percentage of men in the US have heights shorter than 76 inches? Okay. So when I say shorter than 76 inches, would I be shading to the left or shading to the right? I'd be shading to the left, right? Shorter than 76 inches. So my answer is just going to be the area to the left. And so my answer is 0.9772, or in percentage that would be 97.72%. Okay? So about 98% of men in the US are shorter than 6'4". Okay? So about 2%, 2.5%, whatever. So about 1 in 40, 1 in 50 people, 50 men, are taller than 6'4". Does that kind of match our intuitive sense? Kind of, right? Because someone who's 6'4", you'd say, oh, he's pretty tall, okay? And surely we'll probably encounter many people who are 6'4" or taller, but only about 2%. Only about 2%, 2.5%. Does that make sense? Is that okay? All right. Do we feel comfortable with the steps that we took to get here? I asked, what percentage of men in the US have heights shorter than 76 inches? So what we did was we turned 76 into a Z-score by using Z is equal to 76 minus the mean divided by the standard deviation. We turned that into a Z-score, and then we looked up the Z-score in our table to get our answer. Do we feel okay with that? All right, let's try another example. Okay, so again, let's say, just repeat, Z is equal to X minus mu over sigma. And for male heights in the US, the mean mu is equal to 70 and the standard deviation equal to 3. Okay. So I'm going to ask, what percent of men in the US are taller than, let's say, 5'6". Okay, so that's 66 inches. What percentage of men in the US are taller than 66 inches? See if you guys can do this. All right. I'm going to walk around. I want everybody to try. I don't want anybody to just stare blankly at the chalkboard. So look at that as a guide. Draw a picture. Okay. You're going to put a number somewhere in the middle. You're going to draw another cutoff somewhere. You want to shade appropriately, left to right. Find your z-score, you can look it up in the table. When you find your z-square, I would say keep at least 2 decimal places. Okay, keep 2 decimal places. Okay, we're gonna have to work. We got to work kind of quickly here. Let's go down a little bit. All right. Let's talk about the picture we're drawing here. Okay. So when we do these problems, listen up. We should always draw a picture. So what height goes in the middle? 70, the mean, right? And then I'm asking what percentage of men in the US are taller than 66 inches or 5'6". So I would draw a line what? To the left or to the right of 70?
To the right.
Left, right? 66 is smaller than 70, so I go over there. Okay? So my line is over here, 66 is smaller than 70. And then I'm asking shade to the right because I'm asking what percentage of men are taller. Okay? So if you do this, you're off to a good start. Okay? And we know that our answer that we get has to be what? The answer for the area, what percentage has to be? Greater than a half. Good. Okay, so that's our verification check. All right. So the next thing is we're going to find a z-score. So what is the z-score that corresponds to the height of 66? So z is equal to x minus mu over sigma. So x is 66, mu is 70, and sigma is 3. Okay, what is my z? Z is equal to negative 1.33. Okay, we look up z equal to negative 1.33 in the table. Okay, the area to the left is what?
0.0918.
0.0918. Is that my answer?
No.
That is not my answer. We know it's not because it's less than a half. And when we look at our picture, we know that our answer has to be more than 1/2. So what do I need to do? I have to
Subtract
take
it from
this
1.
and I subtract this from 1. So the area over here is going to be 1 minus 0.0918. So the area to the right is 1 minus 0.0918, 0.9082. Okay? And that is my answer. What percentage of men in the U.S. are taller than 5'6"? 90.82% of men in the U.S. are taller than 66 inches. Okay? So about 1 in 10 men are shorter than 66. About 90%, 91% of men are taller than 66, 5'6". Yes?
When you look at 1.3 in the positive, you get 0.9082. Also, is that always true?
When you look at positive 1.33, yes, it's because it's symmetric. So, but I guess if you're very comfortable with flipping images around in your brain and keeping track of positive and negative signs, sure, you can do this, okay? The area to the left of z is equal to the area to the right of negative z, okay? If that makes sense to you right now, great. If it didn't, don't worry about it, okay? Just stick to the way we're solving it. But if you're comfortable looking up positives to get the area to the right, or negatives of the z to get the area to the right, that's fine. Okay. Did this problem go okay?
Yes.
Yes. Okay. Let's try another one. Okay. Huh? All right. So again, for male heights, mu is equal to 70, sigma is equal to 3. And I'm going to ask, what height corresponds to the 90th percentile? What height of US males corresponds to the 90th percentile? What does it mean to be in the 90th percentile?
The top 10%.
Yeah, the top 10%, or it means your height, or the height of the 90th percentile is taller than what percentage?
90%.
Taller than 90%, okay? If somebody is in the 45th percentile, that person's height is taller than what? 45%. If someone is in the 2nd percentile, their height is taller than only 2%, okay? So if someone's in the 2nd percentile, that means only 2% have heights shorter than that, and 98% are taller. If someone's in the 90th percentile, 90% of people are shorter, and 10% of people are taller. All right, so in this case, we're working the other direction. I'll get you guys started here. We're working the other direction. So what I'm giving you is I'm giving you the area. I'm saying this area is equal to what? 90%, 0.9000. And I want to know what is the height that will give me 90%? Can we do this? Do you want me to just do the problem for you, or do you want to try to figure it out? Who wants to figure it out? Who wants to do it? You want to figure it out? No?
Can we have a couple more numbers?
You have all the numbers you need, okay? So, I'm serious. If you see a problem like this, you've got all the numbers you need to answer it, okay? Alright, well, I will lead you through it. What do you think the first step is going to be? We got to find the z that corresponds to 90%. So what is the z that corresponds to 90%? Okay? So the z I get is z equal to 1.28. When I look at 1.28, the area I get is 0.8997. That's about as close as I'm going to get to 90%. Can you see that? Okay? So when we go to the table, right, what we're doing, just, you are search for 0.9000 for the thing that's closest to that. Okay? The number you will find 0.8997. And that is in the row 1.2 and the column 0.08. Okay? So that's what we're doing. You are searching for 0.900 on the table, and when you find it, the number you get is 0.8997. That's the closest you're going to get to 90%. And that means you get a z equal to 1.28. Is that okay? So 1.28 means we are 1.28 standard deviations away from the mean. Okay? Or we can use this z formula. Z is equal to x minus mu over sigma. So 1.28 is equal to x minus mu divided by sigma. What is mu and what is sigma?
70.
Yeah, so I get 1.28 is equal to x minus 70 divided by 3. Can I solve for x?
Yes.
Yes, what do I do? Multiply both sides by 3, then I add 70 to both sides. Okay? This is from algebra, you guys should know this. 3 times 1.28 plus 70, that is equal to x. So we get x is equal to 73.84, I believe. Yeah. $73.84. That is x. This is the answer to the question. What height corresponds to the 90th percentile? 73.84 inches. So about 6'2". About 6'2". That corresponds to the 90th percentile. Okay, a little bit under that, like 1/6 of an inch under. Okay, if we care about the decimals here. Is that okay?
Yes.
So if you see either type of problem on the midterm exam next week, we can do this.
Yes.
Okay? Study these examples. I'm going to do one more example from the normal model, and then we're going to talk about the other table you got, which is the binomial model. Okay? But the binomial model is not hard, all right? Don't groan, all right? I know, it's a lot, okay? You guys are here for 3 hours, you took a quiz at the beginning. I know it's not easy, alright? I'm trying, I'm doing my best to try to make this understandable as much as I can.
Can we take a break?
You know what? We're going to be done at 10 o'clock, okay? I know you guys have been sitting through it. We've got a lot to cover, alright? Alright, one more. One more, you guys. Alright, for the normal model and then the binomial, and we'll call it a night. Alright. I love you guys too, alright? Okay, so let's say cats. I don't know, what is the average weight of a cat?
5 pounds.
No.
30 pounds.
Oh my god.
31 pounds.
Alright, I'm going to make up numbers here, okay? Cats. We'll say the weight of cats come from a normal model. Okay, the mean, mu, I'm going to say is 12 pounds, 12 and a half pounds, and the standard deviation, sigma, is equal to 2.8 pounds. We'll say more than that. We'll say 3 pounds. Okay. And it's really not a normal model, but okay, whatever. It's good enough for this, okay? The weight of cats come from a normal model with mean mu 12.5 and standard deviation 3. Okay, I'm going to ask what percentage of cats, alright, and start this in your notes because you're going to see a problem almost exactly like this on the midterm exam, alright? What percentage of cats weigh between, we'll say 11 pounds and 13 pounds. Okay, let's draw this picture. What number goes in the middle? The mean, 12 and a half. Okay, I'm drawing a line at 2 locations, 11 and 13. Where does 11 go? To the left of 12, okay? And where does 13 go? To the right of 12, okay? I know it sounds silly, but you will not see how many times I will see people, maybe what if I ask between 13 and 15 pounds, okay? Well then 13 goes over here, and then 15 goes beyond that, right? Sometimes people just see 13 and 15 and they put 13 over here and 15 over there, okay? Well, there's no universe where 13 is smaller than 12 and a half, which is then smaller than 15, okay? If we're all counting by the same number system, 13 is bigger, and then 15 is even bigger. Okay, so always ask, should this go to the left or to the right? Is this bigger or smaller? Okay, don't just go into silly habits and drunkenness. Okay. So I want to know how much is in between 11 and 13. How am I supposed to get this area? Okay. Well, what I'm going to do is first I'm going to find the area to the left of 13. Do I know how to do that? Yes. Okay. And then, what will I do? I'm going to find the area to the left of 11. And then I'm going to subtract. I'm going to take this area minus this area. Okay? And if I do that, what I'm left with is the area in between. Can we see that in our head? I'm taking the area to the left of 13, and I'm taking the area to the left of 11, and I'm going to subtract this chunk off of that piece. And then we'll get everything in between. Okay, so there's a few steps. Okay, so how do I get the area to the left of 13? So we're going to find area to the left of 13. What do I do? First thing, find the z-score. Z is going to be 13 minus 12.5 divided by 3. What do I get? 0.1667, okay, or 0.167. So I have to round to 2 decimal places. Your z, always round to 2 decimal places, okay? Not the area, but the z. So round to 0.17. I look up 0.17 in the table. The area to the left of 0.17 is 0.5675. One thing that I want to caution you, do not write 0.17 is equal to 0.5675, okay? Because that is never true. 17% is never equal to 56.75%, okay? Always say the area is equal to that, okay? So the area to the left of 0.17 is 0.5675. Okay, let's do the other one. Area to the left of 11. Okay, so what do I do here? Z is equal to 11 minus 12.5 divided by 3. I get z is equal to negative 0.5.
Yep.
Okay, so I look up z equal to negative 0.5 in the table. All right, and the area to the left of 0.5, negative 0.5 is 0.3085. Good. And so here, this piece is 0.5675. This piece is 0.3085. So the area in between is equal to 0.5675 minus 0.3085. And I get 0.2590.
Overwhelming.
Yeah.
Why wouldn't you add both of those answers and subtract them from one?
Because that is not what we are looking for, okay? What you would be saying is, I'm going to take this piece and I'm going to add another piece and I'm going to subtract that from 1, okay? Or subtract 1 from that or something, okay? That's not what we're looking for, okay? Just visualize, first you're going to take everything to the left of 13, and then you're going to take the area to the left of 11 and chop that off, basically. You're subtracting that.
Oh, because the value you count for 13, it counts for everything to the left of it?
Everything to the left of 13. Okay? Okay. So I hope you took good notes on this problem, because like I said, study this, you're going to see a problem almost exactly like this, except as cats, it's going to say something else, all right? Lions, tigers, and bears. Out on. All right. So the last section we have to cover the binomial model, all right? So that's this other table, all right? We got 15 minutes, so that's plenty of time. binomial model. The hardest part with dealing with the binomial model is saying, am I supposed to use the binomial model in this problem? That's the hardest part, okay? Because if you say, oh, this is a binomial model problem, it's very easy, okay? If you can say, hey, this is a binomial model problem, doing the binomial model problem is very easy. All you have to do is look up a few numbers in the table, okay? The hardest part is saying, do I have a binomial model problem, okay? So what is a binomial model problem? That is when you're going to repeat the same thing several times, but every time you repeat it, there's a probability of you winning or losing, or a probability of you succeeding or failing, okay? So it's like flipping a coin 7 times. And every time you flip the coin, it can go heads or tails, okay? That's a binomial problem. Earlier today you had a quiz, and the quiz said you play a game, and the probability of winning the game is 30%. And we said, you're going to play the game 4 times, okay? If you play the game 4 times, every time you play, you can win or lose. And the probability of winning is 0.3 each time. Binomial model problem, okay? So you're just repeating the same thing a certain number of times. Every time you repeat it, you've got the same probability. And every time you play, either you succeed or you fail, you win or you lose, something like that, okay? So let me just write that down. If you can identify the binomial model problem, figuring out the answer is very easy. The hardest part, again, is saying, oh, this is a binomial model problem, okay? So you are repeating what we call a random trial. Each random trial has only 2 outcomes. Success or fail. Win or lose. Okay, something like that. Okay? 2 outcomes, alright? And every time you repeat the trial or play the game, the probability of a success is the same. Okay. Is that okay with everyone? So examples. You will flip a coin 7 times. And every time you flip the coin, the probability of getting heads is equal to 0.5. Or you play a game of chance 4 times. Every time you play, the probability of winning is 0.3. If you can read a problem and say, hey, this is a binomial problem, the rest is very easy, okay? So once you figure out it's a binomial problem, there are 3 numbers you've got to read the problem and identify. N, P, and X. Okay. So once you figure out that it's a binomial problem, and again, that's the hardest part. So once you figure out it's a binomial problem, You just read the problem, and there are three numbers you need to identify. N, P, and X. Okay? N is the number of times you are repeating the trial. P is the probability of success for each trial. And X is the number of successes that you want.